Are you looking to learn what microservices are, or are you trying to get started and gain some real-world hands-on experience with .NET Microservices? My name is Brookain, and welcome to .NET Mastery. If you have not subscribed to the channel, make sure to do that right now. That way you do not miss any free content that I upload in the .NET domain. Microservices is one of the buzzwords in programming. If you look for a new job, microservices is one of the key features that is coming up more and more often. Every time a system is lagging or it is getting too big, someone will have a suggestion that maybe we should look into microservices. But it is critical to understand what exactly it is and how to implement it correctly. That is my motivation behind this course. My goal is to introduce you to the microservices architecture while giving you a real-world project to see how microservices communicate with each other and what are the problems that we encounter and how to solve them. Microservices is made up of individual API projects in simple terms. But in reality, there is much more to microservices than that. But as microservices are composed of individual APIs, we will be spending quite some time in building small APIs, and then we will focus on the key concept of how individual API communicates with each other and how the microservices architecture comes together. We will be building multiple small APIs in this course, including one API that will be responsible for authentication, and we will do that using .NET Identity. Once we build the APIs, then we will see how API communicates with each other. If you are excited about what microservices are and you want to learn by building a real-world project in microservices, this is the course you are looking for. I hope you will join me in this exciting journey of microservices, and let me show you what we will build in this course in the next video. Let me give you a quick demo of what we will build in this course. We will be building multiple APIs. In the services here, you can see we have 5 API and we have a web project that consumes all the API endpoints. Let me run the project here and I will run all the APIs and the web project. Perfect. Let me open the web project here and you can see we have an e-commerce application for a restaurant. I have already logged in here as the admin user, but if you log out, we have login and register buttons. When a user registers here, they can select a role. So that means we have role-based authentication on admin and customer, and based on the role, we will have different functionality. Let me log in here as an admin role. And once we log in, we will be redirected to the home page where we can add products to our shopping cart. Perfect, we have toaster notification here. Let me add few products here. And we will have a shopping cart where we will store shopping cart for each user in database. I also have coupon codes. If you apply them, the order total is reduced as well. The order total gets updated. Right here in the shopping cart, it is calling the coupon API to retrieve the coupon code and apply that coupon when we hit the button. On top of that, we have a functionality of email cart. When we click there, it will not send an actual email, but it will trigger asynchronous microservice communication, and then the log of the shopping cart will be added to a database of a different API endpoint. If that sounds too complicated right now, do not worry. When we progress with the course, you will understand the complete architecture and the reason behind email cart functionality that I have added here. On top of that, we also have content management as an admin user, where they can manage the coupon, or they can create new coupon, edit or delete any existing coupons. With that quick demo, let me get started from the next video. Now on the APIs here, we will also have a role-based authorization. A customer user cannot create a product, only an admin can create, delete or update a product. There is a lot to cover in the course. Let me get started with all of that from the next video. Before we move forward, this will be an introduction to .NET Microservices. If you want, I have a more detailed course where we will take the complete application that we will build in this video, and I have covered that in the full course as well. On top of that, there is about 10 hours of more content where we will build many more microservices, integrate them together, and I will also show you how to implement that using RabbitMQ. You can find all the details on .NETmastery.com, and there you will find the complete course with all the topics that are covered. That being said, on YouTube here, the course will give you a basic introduction of microservices, so do not get disappointed. You need to understand the basic fundamentals first before you add more features to the existing application. Let me try to answer the big question on why microservices, or what advantage does microservice brings to the table. Microservices are independently deployable. What that means is if in a project there are multiple microservices, we might be working on one microservice at a time. Or it could be possible that each team has one microservice that they are working on, and they can be deployed individually rather than deploying the complete project with all the microservices. Because of that, we do not have dependencies on the other working pieces of the application when we are working with an individual microservice. When we work with monolithic application, there is typically one big application and the team works on that. So when a deployment has to happen, the complete application has to be deployed rather than small application or a small microservice. But when we work with microservice architecture, each microservice can be deployed by itself. Microservices are great when it comes to scaling as well. In a traditional monolithic application, we typically have one server and we might scale that out to multiple instances. But when we have to scale up, we have to scale up the complete server with the complete application. But when we work with microservices, we can increase the resource on the service that needs them rather than increasing it for the complete server. As an example, if there is a microservice that is responsible for handling the bulky exports of our website, and if we want to have 5 instances of that way the downloads are super quick, then it would be much easier to scale that microservices and not touch any other microservice. But if it was a monolithic application, you might have to scale out all the instances of the main server to have multiple instances up and running. You can see because of that scaling is much more efficient when it comes to microservice architecture. Microservices do not typically have bulky code because the complete application is broken down in multiple microservices. The code base of each microservice is smaller as compared to monolithic application because we are breaking things out with microservice. Now that does not mean that microservices will always be small. The only thing that you should remember is microservices. The only factor that you should remember is one microservice would typically be responsible for one functionality. Lastly, there can be many microservices in an application So it could be possible that one of the microservices goes down, but the other microservices will be up and running because all of them are hosted individually. Debugging and making sure that the microservice comes back online will be much faster as compared to a monolithic application. And because of that, it will reduce the downtime of our project. These are some of the basic benefits that microservices brings to the table. Let me walk you through one of them with an example here. We have a front-end application and we have 4 microservices. We have a microservice that will deal with loading all the products and managing that. We have one for managing the shopping cart. We have one to manage the order. And we have one microservice that is responsible for sending out all the emails in our project. Now let's say for some reason email microservices fails, but all the other microservices are up and running. In that case, when a user registers or places an order, a message will be sent to someplace in a message broker. Because the email API is not running, the message will be stored there. Let's say after a few hours, when the email API is back up and running, it will start processing all the messages that were supposed to be delivered and then send out the email. But even if the microservice for email was down, the other microservices were up and running. Similarly, let's say if the order microservices goes down, everything else will be functional, so at least a user will be able to browse the product, add that to the shopping cart. They will not be able to place the order, or they will have to wait for some confirmation. That depends on how we design the application, but main thing that you should remember here is with microservices, if one microservice goes down, the application will still be up and running. That is way different if we have a monolithic application. If in monolithic application the server goes down, the complete application goes down. I am giving you a 10,000 feet overview right now to introduce you to some of the advantages of microservices. But if some things are not making sense right now, or if you have questions about that, please hold on to that. As we progress with the course and start building the microservices, add communication between them, everything will start making sense. Microservices is an architecture where there are multiple microservices or APIs which are loosely coupled and they are independently deployable services. They work in conjunction with each other to produce the complete final solution. When we compare this architecture to monolithic application, this is different because in monolithic application, there is one big solution. Inside that, everything is coupled together and it is tightly bounded. In the diagram here on the blue and gray boxes, you can see individual microservices. Each one of them is responsible for its own functionality. Like in an e-commerce application, we will have a product microservice, we will have a coupon microservice, a microservice for shopping cart, order, sending out emails, and a rewards API that will be responsible to track all the rewards a user gets by placing order. We also have a .NET Identity microservice that will be responsible for authentication and authorization across all the other microservices. Because they are not tightly coupled, they might use different technology, like one microservice can use SQL Server for database, while the other one can use MongoDB or NoSQL, any other database, or even different programming language. Like one can use C#, one can use JavaScript, one can use Java, or any other programming language. It is not required that microservices should follow the same technology stack because they are loosely coupled. Microservices then communicate with each other with a combination of REST API calls or message brokers. Like in this example, you can see we have a service bus in the center with the yellow color. One thing that you should remember is business requirement will divide the microservices, and each service will be responsible for its own functionality. Let me take a look at this with a better example. We will first understand how a traditional monolithic application would look like. If you have a big shopping cart application, you will have products, shopping cart, order management, and all of that will be in one architecture. And all of that will be in one project. On top of that, there will be one database, and there you will have all the tables. You can use entire architecture, create folders, get fancy on how you organize everything, but still everything will fall under one project, and there will be one central database to hold all the data. Now there are few advantages of this architecture. A monolithic application centralizes all the data, and also all the code will be in one central place. If a developer has to make a change, he can run the complete application, and all the pieces of application will run together, so it might be easier for a developer to debug an issue and fix that. Most of the applications are monolithic application, and that works absolutely fine. But once the application starts to grow and you get more and more components and data added, that is when the actual problem starts. In the monolithic application, there are tight dependencies. So later on, if the project grows, then getting rid of these dependencies is a nightmare. That being said, let's take a look at how the same application would be implemented in a microservices architecture. In this case, you can see all the components that we had, like shopping cart, product and order component. They are now individual .NET Core applications or API. On top of that, you should notice all of the three applications also have their individual database, and they do not share a common database. There will be a separate application that will interact with the individual microservices. And with this architecture, maintaining all of the services are now quite easy. Each of the service can be implemented in a different programming language or have a different type of database depending on what the requirements are, and then they can communicate with each other. Now, of course, if all the microservices are in one project, you should technically keep the technology stack same unless there is an advantage, because always remember that if you have more technology, then you will have to spend more time and effort in maintaining them or updating their versions rather than updating the same technology stack. One thing that gets easier is, let's say the order component needs more computation time. You can easily scale that one database if it requires more space, and the other database you can keep them smaller. That way you can scale one instance or one database and not toggle everything else. With that, you should have a brief overview of how architecture is different from monolithic as compared to a microservice architecture. In the gray box here, you can see we have different microservices for product, coupon, shopping cart, order management, email, and rewards. Each one of the microservices will have their individual database. We will have a .NET Identity microservice that will be responsible to provide the JWT token for authentication and authorization across all the other services that we have. We will also build an MVC application that will interact with all the individual microservices to bring everything together. There will also be a gateway. MVC application will interact with gateway, and gateway will redirect the request to the individual API. When we have to work with communication within services, like shopping cart here, you can see communicates with the product service, communicates with the coupon service, and so on. Those communication will be synchronous communication. We will see how to accomplish them, and then you can see dotted lines here that are using service bus for communication. Those communication will be asynchronous communication, and we will see how to pass message to the service bus, how to extract them, and process all of that. I have also written port number that we will add to the different API endpoints right here. So you can take a picture of this architecture, keep that on the side. That way you will always have a rough idea of what is the architecture of our project that we are building in this course. Let me walk you through on what will be all the tools that will be needed for this course. First thing will be Visual Studio and .NET 8. Right now .NET 8 is in preview, so if you are using Visual Studio, you will have to download the Visual Studio 2022 preview version. If you want to follow along the same course in Visual Studio 2022, then you will use the .NET 7 and not .NET 8. For .NET 8, you will require the preview version. Next thing, for the database, we will use SQL Server. Now make sure to use SQL Server and also install SQL Server Management Studio. You will have to install both of them to get SQL Server Management Studio up and running on your local machine. Finally, you will require an Azure subscription. We will be using Azure Service Bus for communication between the APIs that we will build. That will not be a free service. I believe it will cost about $10 for the whole month, but that should be sufficient to learn microservice architecture. If you have never joined Azure, I believe they give $150 to $200 in free credit to try the Azure services. But these are the tools that you will require for this course. Before you move ahead with the course, let me clear some things here. I want to cover what this course is not about. When someone hears microservices, they right away think about Docker. That is a misconception. Microservices and Docker are not related. You can have a monolithic application with Docker as well. Docker has its own advantages and why you should use that, but when it comes to microservices and learning the fundamentals behind how APIs communicate with each other, what are the pitfalls there, we do not want to add any other complexity rather than what is needed for microservices. If I add Docker onto the course, it will make the course way more complex for someone who wants to learn microservices. Because of that, I want to make clear that Docker will not be covered in this course. Next thing that I want to clear is with microservice architecture, one advantage that we have is when we have different API endpoints, we can use different technology. Like in one API, we can use the .NET API. In the other one, we can use minimal APIs. We can even use a completely different programming language for other API. And same applies for database. We can use SQL Server. We can use MongoDB. Sky is the limit when it comes to multiple API endpoints because they are not related. But if someone is getting started on learning microservices, that is not the route that you should take. What I will rather do is I will be using .NET APIs, I will be using Entity Framework Core, and I will be using SQL Server in all the APIs that we will build. That will make sure that you do not get stuck in multiple technology stack and you understand the main concept of what is a microservice, how microservice communicates with each other, and how the architecture comes together. Once you understand that, if you have to implement the same API in different programming language or different database, that is not a big deal. Let me walk you through on what are the prerequisites that I expect for someone taking this course. You should have a basic understanding of .NET Core. What I mean by that is you should be comfortable with MVC programming language and how web applications are built with .NET Core. On top of that, we will be using Entity Framework Core, so you should have a basic understanding of CRUD functionalities using Entity Framework Core, and then finally microservices is basically small API endpoints. Even though I will build everything from scratch, I expect you to have a basic understanding of the .NET APIs with Entity Framework Core as well. But if you are not familiar with these functionalities, I have free course on .NET Mastery that will walk you through all the fundamentals that you require for API with Entity Framework Core as well as .NET Core MVC. Make sure to get those courses from .NET Mastery before you proceed further if you want to get a refresher on the basic introduction. Throughout the course, you will require some project resources, or if you want to access the PowerPoint presentation or images that are used, you can go to courses on .NETmastery.com and navigate to the course here. We have .NET Core Microservices. If you go to the Details tab here, I have the link here for GitHub code that will take you to the Git repo. Then make sure to download the course content because that will have all the content that you will require, like snippets, images, and so on. If I open that here, you can see there are two folders. I have the content for old course if you are taking that, but that will be removed in December of 2023. The current course is .NET 8 course, and that is what you should be doing. There I have all the images, and in snippets folder, I will have the code snippets with HTML that we will use during the course. Make sure to download project resources before you continue in the next video. On top of that, I also have free content on .NET Mastery that you can check here, and many other courses if you are interested. But with that, let me continue back to microservices. I will open my Visual Studio here, and we will go to File, New, Project. Now we need to select what type of project we want. We know we are building a microservices architecture, so it makes sense to divide everything in their individual folders. But right now, we do not have anything with an empty solution. It was there in the templates before, but for some reason it has been removed. So let me create an ASP.NET Core empty project. Project name is not important, but the solution name here, let me change that to be Mango. I will be deleting this temporary project. I only want to create an empty solution to get started. Framework will be .NET 8, that looks good. We do not want to use the top level statements. Let me hit the create button. Perfect, it has been created here. Now like I said before, we do not want any project. Let me delete this project. Let me right click, open that folder, and I will remove the web application 1. We only have an empty solution. With that configured, let me create folder in the next video. Rather than creating everything in the solution here, it is better if we organize that in a folder structure. We will right click in the solution, add a new folder, and I will call this the front end folder. Here we will be placing our front end application which will be the MVC web application that will call our microservices. Next folder that we want will be a gateway folder. When we work with microservices, initially we will be invoking the microservice directly, but down the road we will learn some advanced concept with gateway, and that we will place inside the gateway folder. After that we will have something called as integration, and that folder will have something that is related to messaging, which I will explain later on as well. Right now these are only empty folders, but as we add projects in this folder, everything will start making sense. The final folder that I want will be the most important one, and that will be services. Inside services, we will create all of our different microservices, or rather the API endpoints. We will get started with creating our first API endpoint. That will be a coupon API where we will be creating coupon codes that we can apply to our product. So inside the services folder, we will create a new project, and that will be an API project. We will search for API here. We have the ASP.NET Core Web API. Project name, I will call that mango.services.coupon API. That looks good here. We will be using .NET 8 and we will be using controllers. We do not want minimal API. That looks good. Let me create the project. With that created, let me run the application here and see how that looks. We need to allow access. That is okay. And perfect. In the background here, you can see it is running on localhost 7123. Now when we are working with the microservices project, we can use port number that are closely assigned rather than something random. If I switch back to the presentation here, you can see for the coupon API, we were planning to use port number 7001. We can go back to our code and we can update that. Let me stop the application here, and that will be inside properties, launch settings.json. Here we have 7123 for HTTPS. Let me make it 7001. Let me switch back. And yep, that is exactly what we have for coupon. Save that and run the application. Perfect. That looks good. We have created our coupon API. That API will be responsible to perform CRUD operations on the coupon model. We do not have that yet, and for that in the coupon API, we will create a new folder for models. In there we will create our model, which will be a class file. I will call that coupon.cs. When it comes to creating a coupon, you can be very fancy, but I am going to keep things super simple. We will have a coupon ID, a coupon code. A discount amount will basically be how much discount they will get, and if there is any minimum amount after which the coupon should be applied. That will be the 4 properties that I want in my database. Right now we only have our model, but now we need to think about adding that to our database. But before we go into the database logistic, when we are working with an API, this will be the core model of our database. Let's say there was also some other properties like date time, and we had last updated as well as created date. Now those properties, when the front-end application is consuming, we do not need to pass that. They are only for the logging purpose. So it is possible that every time when someone is accessing a coupon, we do not want to pass all the field. For that, typically in an API, we do not return the complete object. We rather return something called as a DTO, and that will have all the properties that we want. Now right now, to keep things simple, I am going to make DTO and coupon class the same, but that is a common scenario that you will encounter whenever you are working with an API. In the model folder here, I will create a new folder for DTO, and in there I will add a class that will be coupon DTO. Like I said before, the properties will be same for now, so let me copy and paste them here. One thing I would also like to point out is you can see based on the project, I have different tab color. Right now I only have one project, so everything is in one color, but if you want to enable that feature, you can click on the gear icon here, and there is colorize document by I have project selected. That will give you the same colorful tabs like I have. But this looks good for the coupon DTO. How we will do conversion from coupon to coupon DTO and other concept we will cover when the time is right. We have added the coupon model and we also added coupon DTO, but we need something to convert coupon DTO to coupon or vice versa when we have that requirement. We can do that manual mapping, but it is tedious, and rather there are many packages that we should use to enhance our speed and make code more elegant. One of those packages is AutoMapper, and that, as the name suggests, is responsible for mapping one object to other. So we will add AutoMapper to our project, and we need to store our coupon in a database. I will be using SQL Server for that, and for that also we will have to add NuGet packages to configure Entity Framework Core to access our database. In the Coupon API project, we can right-click, Manage NuGet Packages. We will go to the Browse tab here, and the first package that I want is AutoMapper. AutoMapper, let me install that one. And we want to use AutoMapper using dependency injection. For that we will require automapper.extensions.microsoft.dependency injection. Perfect, we added both the project for that. Now we need Entity Framework Core. You can see IntelliSense is already displaying me those packages, but if not you can search for them as well. Right here we have the SQL Server. Let me install that package. Perfect, that looks good. Next package we want is the Entity Framework Core package. And we have Microsoft.entityframeworkcore.tools. We will be using the tool package to add migration. So let me install that. And here if you notice I have the include pre-release selected. Because of that I am able to use .NET 8 Preview 3. If you uncheck that, then the version you will see is .NET 7. We want to use .NET 8 for our project, so make sure that you have this checked and then you install the right package version. One thing that I will point out right now is if you are using Preview 3 and let's say Preview 4 or a next version is released, keep using the same version in that microservice. If you have a different microservice, you can use a different version there, that is okay. But inside the same microservice, if you use different version, things might not work. So always keep that in mind when you are adding NuGet packages. Along with that, IntelliSense is also displaying authentication.jwt bearer. We do not have security in our API right now, but later on we will be adding API. We have that package here, so why not install that in our API as well? If I go to the install tab here, perfect. You can see all the packages that have been installed. With that, let me continue from the next video. We need to create a database using Entity Framework Core. We have already added the NuGet packages for that, so all we have to do is add something called as a DB context. I will right click on the project here, add a folder for data, and in that data folder, I will create a class file, call that app db context, or sometimes I like to call that application DB context. When we have to configure Entity Framework Core in our project, this class must implement the DB context class that is inside Microsoft.Entity Framework Core. Along with that, there is one more configuration that we have to do is whatever we get in the constructor here as DB context option, we have to pass that on to the base class that is DB context. What we have here is a default setting that is required for Entity Framework Core. And with that, when we have to create our coupon table in the database, in the DB context here, we have to create something called as a DB set for that class file. So DB set here, that will be on the coupon class, add the using statement, and what do we want to call that table in our database? I will give that a plural name, and this coupons will be the table name in database. Then if we go to the coupon model here, we can add some data annotation like coupon ID will be primary key of the table. Then coupon code here, make that required. Discount amount, we will also make that required. With that configured, we have created our application DB context file, but we need to create database. For that, we need to do some configuration inside program.cs file. We need to configure DB context inside the program.cs file. That file is basically the main file of the application where you will configure all the services and the request pipeline. Right now we want to add something to our services here, and that is application DB context. We have to tell our application that hey, we will be using Entity Framework Core for our database, and we will be using SQL Server, and the app DB context, or rather the DB context for that, is inside the file app DB context. We need to define that right here. So on builder.services, we have the add DB context method, and there we have to define the class that implements DB context, that is app DB context. And here we have to define some option. That option will basically tell that hey, we will be using SQL Server for our database. So option dot we have a method use SQL Server. You can see that is inside Microsoft.Entity Framework Core. And then we have to pass the connection string. Now we can hard code that connection string right here, but that is not a good idea. What we should rather do is inside the app settings.json, we can define connection string right here. Now in production, you can use the Azure Key Vault, but we will not go into those complexity. We will be using app settings for now. Right here, we will define a section, or rather you can see there is a predefined section for connection strings. We can directly use that. We can give it a name. Let me call that default connection. And there I will write, or rather define the connection string. First we have the server name, and for that we will open SQL Server. There when we hit the connect icon, we have a server name. Now whatever server name works for you, you can copy that. I will copy this because you can see when I try to connect, I am able to connect there. For many of you, if you add a dot and try to connect, it might work. I do not have that configured on my machine, but I have the local DB, MS SQL local DB. So I will copy that, paste it right here. After that, we have to define what will be the database name. So we will add a semicolon, database, and then let me give it a database name of mango_coupon. After that, I will add couple of more fields here for trusted connection to be true and trusted server certificate to be true. With that, our connection string is looking great. But how can we access that connection string and pass it on right here? If you notice in app settings, we have default connection in a section with the name of connection string. Because of that, we have a special method that will only work for a section with the name of connection strings. If you had that as connection string or anything else, it will not work. But because we are using the default one, on builder.configuration, we have a method getConnectionString. And if we go there, you can see it retrieves the value with specified key from connection strings section. And that is exactly what we have. In there, we have to pass the name. Key name, if we go back, I can copy default connection, paste it right here. We need the closing bracket here, and perfect, that looks good. That will retrieve the connection string and pass that to use SQL Server. Now that we have application DB context configured here, how do we create our table and database? It is simple. We will be using something called as migration. For that, we will go to Tools, NuGet Package Manager, and Package Manager Console. Now, if you don't know about migration or how Entity Framework Core works, I have a free course on API on my YouTube channel, so make sure to take that course to get more familiar before you proceed on the course. Because even though I would love to start from scratch, I want this course to be focused more on microservices and not on API and how the nits and grids of API work. So next we need to add a migration. Let me say add migration, add coupon to DB, add that. Perfect, migration is added here and it is creating the coupon table. When we need to create this, all we have to do is run the command update database. But when we do that, you will see our first error message. You can see keyword not supported, trusted connection. I want you to Google the error and find out what is the solution. I hope you were able to figure that out. I intentionally introduced an error while pasting it here. This must be trusted_connection. If there is any mistake in the connection string, when you try to update database, you will see error message like this. After you fix that, if you run the command update database, you will still see an error message, and this error message might go away when you are programming. The error that you see here can easily be resolved if you right-click on the project and select Edit Project File. Invariant globalization, when that is true, that is when we see that error message. I have already reported that to Microsoft, so by the time you are taking the course, this might already be fixed. But once you disable that, if you do update database again, it will work. And perfect, that works. If I go back to SQL Server and refresh the database, we have mango_coupon, and perfect, we have the coupons table. We have 4 columns there, so our table is created successfully, and we were able to push our migration. We have created our coupons table in the database, but we need to populate some entries in there. What we can do is I can seed some database directly. That way we do not start with an empty table. Seeding database is very simple with Entity Framework Core. Right here, we have to override the on model creating, and in there they have a default model builder. Before you seed any record on the base class, we have to pass the on model creating with the model builder that we receive in the parameter. If you do not add this line, things will work right now, but later on if you add identity, it will not work. So it makes sense to add it and forget about that. You can think about this as a basic configuration that is needed to seed some record in the model tables. After that, to seed something, we can use the model builder.entity on coupon. We have a method hasData, and there we can pass a new coupon object. That will be the record that will be created in your database. We can add some dummy record there with the coupon ID of 1, coupon code, let me call that 10 off, discount amount and minimum amount. The next one, let me make it 2. I will call that 20 off, $20 discount and minimum amount, let's say $40. Perfect. Now how do we seed our table? If you open the package manager console and if you add a new migration, call that seed coupon tables. Perfect. You can see it is calling a method insert data and it is inserting 2 records. That looks good. Now rather than updating database, what I want to do is if there are any pending migrations, I want when I run the application, it should automatically apply those migrations. That way we do not have to write the command update database. Doing that is super simple. Let me close all the tabs here other than appdb context. Well, not appdb context. I wanted program.cs. That is the configuration file. Here, let me create a method. I will call that apply migration. What exactly do I want to do that? I want to get the application DB context service here and check if there are any pending migration. If there are, then I want to apply them. For that, we will have to write a using statement, and I will create a variable with the name of scope app.services. We will create a scope there. That will basically get all the services. Now from this service, we only want the required service of application DB context. So I can say variable underscore DB is equal to scope dot service provider. There we have a method get required service. We want the service of app DB context. That will give us the application DB context here, and on that application or app DB context, we can check if underscore DB dot database, there is a method get pending migrations dot count. So if that count is greater than 0, that means there are some migrations that have not been applied to the database. In that case, we will say underscore DB dot database dot migrate. That will automatically apply all the pending migrations to the database. We need to invoke this method. So in our pipeline here, we can add apply migration. And with that, whenever the application is restarted, it will check if there are any pending migrations, it will apply them. If there are not, it will ignore that. When we run the application, it should have applied our migration. Let me switch back here, and perfect. With that, we have added the logic to automatically apply any pending migration. Our database and model setup is looking great. Now we can finally add a controller in our API. We have a default weather forecast controller. Let me delete that along with the weather forecast model. I will add a new controller here, and it will be an API controller, empty controller, controller name. Let me call that coupon API controller. Default route here will be API / and we have the coupon API, that is the controller name. First endpoint that I want to implement is retrieve all the coupon and display them. In order to retrieve our record, we will be using Entity Framework Core, and for that we need appdb context using dependency injection. So I will have a private read-only appdb context here. Let me call that underscore db, and inside constructor appdb context, I will call that db, and underscore db is equal to db. Now the endpoint here will be an HTTP GET endpoint, and let me call that public. Return type, let me keep that as object, and here it will be a GET request. In there we will add a try catch block. Inside the try logic, the return type will be an IEnumerable of coupon. Call that as obj list. We have to retrieve that from _db.coupons.toList. We will retrieve that using entity framework. That looks good here. And finally, we will return the obj list here. If nothing works here, we have exception. We will return back null. That looks good for get all. Let me run the application and see if that works. And perfect, we have the endpoint using our Swagger documentation. If we try that out, perfect, we can see both the coupon here, so that looks good. I can copy this endpoint, paste it here. Next endpoint will be if I want an individual coupon based on the ID. Here, route, I will have to define that we expect an integer ID. If you do not write it, then things will not work, and let me show that. But based on the ID, we need to filter here. So we can say first here, where u goes to u.couponid is equal to the ID, and return that back. It will be a single object and not a list. Save that, and let me run the application. The Swagger documentation will display an error message. That is because when Swagger is looking at the endpoint here, it will basically think that, hey, both of them are a GET request. It is not able to differentiate that, hey, this GET request requires an integer ID. If you want that to be explicit, you have to define a route here, and in that route, I have defined here that ID will be provided, which is an integer. With that, if you restart the application, now Swagger will be able to tell difference between both the endpoints. And if we try that with an ID of 1, that works. If I add an ID of 3, you can see we do not receive any response back because that is an invalid ID. So perfect. As long as ID is valid, we will get that back. With that, we have the get all and get individual coupon endpoints in our API. We have 2 endpoints, and in those endpoints, we are returning different things. But what if we want to have a common response for all the endpoints in our website? Like right now, if there is any error, we cannot return that back. We are returning the coupon DTO. If we want something to be common for all the API endpoints in our microservices, that way whenever an API or rather multiple APIs are being consumed by an application, it can be sure that okay, the response that I will get from API will always be in one object format. And that will be a great architecture for our API response. What we will do is in coupon API DTO, let me create a new class. I will stop the application here. Let me add that. I will call that response DTO. When it comes to any response here, what are some things that are needed? First is the object itself. It can be a coupon. It can be an IEnumerable of coupon. If you add multiple other tables, it can be those object. So we will not know exactly what will be the return type. So I can call that an object, and I will call the property as result that will have the final response like a list of coupon or an individual coupon. Along with that, we will add a Boolean flag which will denote if the request was successful or not, and I will add a string here that will be message. So let's say if there are any errors or if there is any success message, we can display that in that variable. These three properties will be sufficient, and that way we will have a common response for all of our API. Now we need to return response DTO in the coupon API controller. Let me create a private response DTO, and we can initialize that in constructor. When we are returning here, we can set the underscore response.result. That will be the obj list. And at the end here, we can return back the response. The return type here, we can modify that. We now know it will be of the type response DTO, and that will apply for both the endpoints. If there is any exception here, we can set the isSuccess to be false, and message will be the exception.message. One more thing that we can do is inside the response DTO isSuccess, default value we can set that to be true, and for message we can make it an empty message. And perfect, that looks good. Let me scroll down and modify it here. We will have underscore response dot result. We will have an obj here. Let me rename that, and in the catch here we will copy and paste that. Return will be underscore response. Perfect, that looks good. Let me run the application and validate to make sure everything is working. In the ID here, if I enter 2, perfect, we have result is success is true. If I add something invalid, perfect, the success is false here, and message we have sequence contains no element. Let me try the get all here, and that looks good. With that we have added a common response DTO, and that will be the return type for anything that we will return from our API. Right here on the top you can see it is basically clustering all the main methods, but I do not like it that much. I prefer to keep things simple like it was. But they have modified that with the new version of Visual Studio. I hope there will be a setting to turn it off, but right now you might have to deal with that, so fingers crossed if they update that. But next thing that we want to work on here is when we are returning something here, you can see we are returning the coupon object. Like here we have a list or IEnumerable of coupon, and down here we are returning the coupon itself. We have added DTOs in our project. We should not return the coupon or the data object itself. We should return the DTO. What you might have to do here is you might have to do a manual conversion. Like here you can say coupon DTO is equal to new, and then you can map the individual, like coupon ID is equal to obj.couponid, next one coupon code, then we have discount amount, and we have minimum amount. Once you do the conversion, you can return back the coupon DTO. Right now it is looking ugly. Think about if you had to do that for all the endpoints in all the microservices. That will be a nightmare. Thankfully we have AutoMapper, and for that inside the project I will add a new class file. Let me stop the application. You can do all of this mapping configuration directly in program.cs, but I like to separate it out. That way the program.cs is not too clustered. I will call this file as mapping config here, and there we want to add the configuration for AutoMapper. We will add a static method here, and return type will be mapper configuration that is inside AutoMapper. Let me give it the name of register maps here, and inside there we want to add a mapping that hey, if you get a coupon DTO, you should be able to convert that to coupon and vice versa. Now with AutoMapper, it is pretty smart. As long as the property name are exactly the same, it will automatically do the mapping. And you can see we have the exact names in coupon and coupon DTO, so that should work. We will create a variable here, mapping config is equal to new mapper configuration, and there we will define the option. So config.createMap, there we have to define what is the source and what is the destination. We can say coupon DTO will be the source, destination will be the coupon object. We can create the other mapping where we want to map from coupon to coupon DTO. Finally, we will return the mapping config. That way we are telling AutoMapper that you might have to create a mapping from coupon DTO to coupon and vice versa. With that, we have one more thing. When we add the mapping config, we have to register that in our services. So right here, we will be creating iMapper object. Call that mapper is equal to, on the mapping config, we have the method that we created, register maps. On there, we have to create the method createMapper. Once we create this mapper here, we will have to register that to our service. So builder.services.add_singleton, that is the lifetime, and we will register our mapper there. Finally, we want to use AutoMapper using dependency injection. For that, you will have to add the line builder.services.add_AutoMapper, and there you have to pass the appdomain.currentDomain.getAssemblies. That is the basic configuration that you have to do to add AutoMapper to your services. But with that configured, now you can easily inject AutoMapper in your controller. We will do that using dependency injection, create a private iMapper, and we will have iMapper here. Call that as mapper, and underscore mapper is equal to mapper. Where we have to do the mapping here, we will say underscore mapper.map. What is the return type that we want? That will be the coupon DTO, and here we can pass the obj. We will cut the result here, paste it here, and perfect. What this single line will do is it will automatically convert the obj that is of coupon type to coupon DTO and return back. Pretty smart. We need to convert an IEnumerable of coupon to an IEnumerable of coupon DTO. We can use mapper here, .map. What is the return type? That should be an IEnumerable of coupon DTO. Add that here. And we need to pass the source that is inside the obj list right here. Perfect. With that, if we run the application, everything should work the same. Let me try that here. And perfect. You can see the response is valid, and with that we have added AutoMapper to our project. We have added two endpoints. When we typically retrieve coupon, we might have situation where we want to retrieve coupon based on the coupon code. We will leave the ID here, but we will add one more get configuration where we want to get coupon based on the coupon code. I can switch back here. Let me copy this HTTP get method, paste that one more time. The route we will have to update that, so let me add a new method name here, get by code, and there we will expect a string which will be the coupon code. Let me modify that here. And rather than first here, I can do first or default. It might be empty. We will say .coupon code .toLower is equal to code .toLower. That way coupon will not be case sensitive. Once we retrieve the object, we can return that back. If I save that, hot reload will kick in, and perfect. Let me try that. If I enter 12, the result is null here, but let me try 10 off, and perfect, it returns back. Now if the obj is null here, if obj is null, then we can set the isSuccess to be false. With that, if I go back, and if I try 12 here, success is false, and that looks good. If you do not want to add this, you can only use the first here. It will throw an exception. We are catching that, and that should also work. Let me see that. Perfect. You can pick whatever route you want. Get is looking good here. We need to add a method to create a new coupon. Copy and paste that again. HTTP post to create. We do not want any route there. We can rename the method here to be post. When we are creating, we will receive something in body. So from body, and we will receive a coupon DTO. When we receive that coupon DTO, we will have to convert that back to a coupon. Only then we will be able to add inside the underscore DB. Let me show you that. If on underscore DB.coupons, there is a method to add an entity in Entity Framework core, and here if I pass coupon DTO, it will not work. You can see it cannot convert from coupon DTO to coupon. So here we have to pass the coupon itself. We will have to convert that. So coupon obj is equal to underscore mapper.map. I need to convert that to a coupon object, and we will pass the coupon DTO. When we create, we will pass the obj, and with Entity Framework core, when you create, update or delete anything, you have to save the changes. If you do not save the changes, then this will not work. In line 80 here, we are telling Entity Framework that hey, you have to add this record in coupon table. You have to add this record in coupon table. But on line 81, when we save the changes, at that point it will go to the database and create that record. So it is important to save the changes. Once you do that, when we return back, we will return DTO and not the coupon object, so we can map the obj back to coupon DTO. If I save the changes, I go back, hot reload kicks in, I do not have to restart the application, and that is great. We do not want the get here, we want to try the post. Let me add some dummy discount amount and minimum amount, post that, and perfect. You can see the success is true here. If I go to database, great, that coupon was added. After that, I quickly want to add 2 more endpoints, one to update a coupon, which will be HTTP put here. Call that as put. We will receive the coupon DTO. After we convert the object to a coupon object, rather than add, in Entity Framework core, we have the update method, and that will do everything for us. It is pretty smart. Based on the ID in the obj, it will find that coupon record and update all the other fields that are provided right here. After that, let me copy this, paste it one more time for HTTP delete. Rename that to be delete. When we are deleting, I do not want the complete coupon. I can only get the ID that user wants to delete. Based on that ID, we will have to go to database underscore db.coupons, coupons.first, and u goes to u.couponid is equal to the ID. We retrieve that coupon, and on coupons with entity framework, we have a remove method that will remove the object. We save the changes. We do not want to return anything back here. That looks good. Let me go back. Our application is already running. Let me try to update first. The coupon ID is 3. Let me make sure. Yep. I will update everything to be 33 here. Let me go down. That works. If I double check here, perfect. Let me try delete now. Delete the coupon ID 3. Success is true. And let me see here. Great. With that, all the CRUD functionality for our coupon endpoint are working as expected. Now we want to work on a front-end application that will be consuming the coupon API. We have created a folder for that. If you right-click, add a new project in there, that will be the web project. When we are working with the front-end project to consume our API, we can go with Razor project or an MVC project or even Blazor project. For this course, I will be using ASP.NET Core Web App with Model, View and Controller. That will be MVC. For name of the project, let me call that as mango.web and let me create that. We do not want any authentication type. Keep that as none and let me create. Perfect. With that, we have created our web project where we will be consuming the coupon API. We want to consume our API in the web project. But when we consume any API, we typically have to write few things like what is the type, is it a get, post, put, delete, and then we have to specify the URL along with some data if you are posting some record. Like in the API here where we have the coupon API, you can see sometimes we can pass the ID in URL, but sometimes we have to pass the object in from body. And for that, similar to the response DTO that we added in coupon API, we will have to create a request and a response DTO in the web project. I can copy the response DTO from here and paste it in the models folder. Well, let me copy and paste that again. That did not work. And then if you open that, we will have to change the namespace here to mango.web.models. Now based on the tab coloring, I can see that yellow one is the web project and the blue ones are the API. Again, I have enabled that right here, colorize document tab by project. You might be thinking that, hey, we have a response DTO that is common in two projects. Why don't we create a third project where we have all the common models? Now that might seem okay for the course that we are doing, but when you are building a real-world microservices architecture, all of the project might not be in the same solution. Like if you have 7 different microservices, the services might be in their own solution by themselves, and at that point, sharing the common model folder is not something that is common. And because of that, even though we will have to copy the models from API in the web project, I will do that manual approach because that is the real world scenario which you will encounter. Because web project will have a different models that are inside that project, and coupon API right now, even though it is in the same solution, but in real world it might be in a separate solution by itself. So keeping the models isolated to their corresponding project is important when you are building microservices. Now we have the response DTO that we will get when we call an API. But we need to create a model here which will be request DTO, and that will have everything that is needed when we are sending a request. Right now let me add four properties in there. First one here is API type that defines if it is a GET, POST, PUT or DELETE request. Then we have the URL, and data will be populated when we are posting or updating some record. Finally, we have added a field for access token, but we will not be using that in this section. Later on, when we add authentication and authorization, we will see how to use access token. Now, rather than having a string for API type, let me create an enum for that. In the web project here, let me create a new folder for utility, and inside there I will create a class file, static details, and there let me add an enum. I will give that a name of API type. We will add GET, POST, PUT and DELETE. Save that here, and then the type here will be API type. If you press Ctrl dot, we can add the using statement, and the default one will be API type dot get. That way we will avoid any mistake when we are using an enum. But with that we have request DTO and response DTO in our project. We have the request and response DTO. Let me close all the tab. From the web project we will be calling the coupon API. When we add more APIs in the project, that particular service will be responsible to call all the other API endpoints. And for that we have to make it more dynamic. In the web project, let me create a folder of service, and in there create a new folder for iService. Where we have the interface, we will add a new item. The interface name, let me call that iBase service. And let's think about what will be the method that we will create here. Let me call that method as sendAsync, and when we will be making any API calls, in the parameter here we will be passing the request DTO that we created. That looks good for the parameter. But what will be the response that we will get back from the API? If you remember, in Coupon API, we have all the response that is aligned with the response DTO. We want to make this method asynchronous. Let me add task there. And that looks good. And with that, the interface is looking good. Let me implement this interface in the next video. We need to implement the interface for our base service. Inside the service folder, I will add a new class, call that base service. That class will be implementing the iBase service interface. Let me do that here, and I will add the async keyword. When we have to make API calls to, let's say, Coupon API this time, we need the HTTP client. Previously, what we used to do is in the constructor here, we used to inject the HTTP client, but with the newer versions of .NET Core, they have moved away from HTTP client, and now the preferred route is using iHTTP client factory. So let me inject that. It will be a private read-only field, iHTTP client factory. We will get that with dependency injection. Now right now we have not configured our application with the client factory. I will do that later on, but right now I have directly injected the client factory, and let's say it will give us the correct implementation of what exactly we want, and the only thing that we want to focus on right now is writing the method to make that API call using the client factory. From the client factory, we have to create a client itself, and that will be on HTTP client factory. We have a method create client, and there we can give it any name. Let me call that Mango API. When we are making a call, we will be using the HTTP request message, and we can provide or configure options on that message. One of the important aspect is on message.header, we will say that we are accepting application/JSON. Now in future, when we add authentication, we will also have to add that token here. So let me add that in a comment. Then on message, we have something called as request URI. There we have to specify the URL that we will invoke to access any API. If you examine the request DTO, we have that right here. How that will be populated, do not worry about that right now. We have to assign that right here. So new URI, and I will pass the request DTO dot URL. Then if it is a GET request, we are okay. But if it is a POST request or a PUT request, we need to serialize the data that we receive here and add that to message.content. We first have to check if the request DTO.data, if that is not null, then we have to serialize. For that, I will say message.content is equal to new string content, and there we will use JSON convert. We will have to add the NuGet package nudensoft.json. Let me add that. And then we have serialize object there. I will pass the request DTO.data. When you are serializing, you can also define the encoding. So we can say encoding UTF-8, and that is application/JSON. That looks good for the data. We have the request message. When we send that, we will be getting a response. Let me create a variable to hold the API response. Now one thing that we have to set here is in the request DTO, we will get the API type. Based on that, we will have to configure the message.method. So if it is a GET here, we will configure that and so on. Rather than if-else condition, a switch case would be a better scenario. So on request DTO.API type, we will be adding case. We have that in static detail. So if that is a GET here, let me remove this and add a using statement. Perfect. If it is a GET here, we can say message.method is equal to http method.get. But get, let me keep that as the default one. So let me change this one to be post here. That looks good. We will add a break condition. Copy that and paste it about 4 more times. We will have the delete here, change it here. Next, I will have the put request. And finally, if nothing is defined, we will have our default case here, which will be the get request. And I should have left the break command there. Perfect. Based on the API type, we are setting the message.method. Final thing that remains is to send this and get a response back. Response we will store in the variable API response, and to invoke or send that, we will be using client.sendAsync. Pass our message inside there. When we get the response back, we know from the API we will be getting a response DTO. We can always deserialize that. But before we do that, we can check the status code of the response that is received. So let me add a switch condition here. On the API response, we have something called as status code. The first case that I want to handle here is http status code .not found. Right now we will handle all the exception or error cases first, and let me add the using statement. If it is not found, we want to return a new object, and that will be of the type response DTO. We will set the isSuccess to be false, and we can set the message here to be not found. Copy that and paste it about 3 more times here. Next status code that I want is forbidden, then unauthorized, and internal server error, which is 500. We will also add the corresponding error message here, and that looks good. But if it is not in one of those faulty scenarios, we will add the default condition. Inside there, we have to retrieve the content from API response. So we can say variable API content is equal to await API response dot content dot read as string async, and then we will deserialize that to a response DTO. We will have a variable here. Let me call that API response DTO is equal to JSON convert dot. Now we will be deserializing the object into response DTO. I will pass the API content there, and whatever we deserialize, we will return that back. That is perfect for our condition here. We can add this inside a try-catch block here. And if any exception is caught here, we will basically return a new response DTO. We will set the message with the exception is success will be false. I believe with that the method that we have to send async is looking good. The only way we will be able to test everything is once we wire up all the service for coupon, then we can see this in action. We have the base service right here. We need to call our coupon API, and for that we will be creating the coupon service. In the service folder, let me create a class file. It will be an interface. I will give it a name of iCoupon service. When we are working with the coupon service, we need the coupon DTO, because if we are getting all the coupons, what will be type of that model? That will be coupon DTO, and like I said before, we will not be sharing project. We will rather create the coupon DTO inside the web project. So let me copy coupon DTO from the coupon API and paste it where we have the model right here. Modify the namespace to be mango.web.models. That looks good. After that, we have to work on the coupon interface right here. What will be the return type when we invoke the API? That will be response DTO, and it will be async method. So let me add task there, response DTO. Let me make that nullable. First one, let me call that get coupon, and here we can get that based on the coupon code. Copy that and paste it few more times here. Next one, let me call that get all coupons. And let me add the async after all the methods. When we are getting all the coupon, we do not need any parameter. I can close that. And let me copy this, paste that few more times here. I will have get coupon by ID here, where we will pass the integer coupon ID. Next, we need to create or update a coupon. So we have create coupon async. When we are creating or updating, we will pass the coupon DTO. For update as well, I will pass the coupon DTO. Last one will be delete coupon async. When we are deleting, we only pass the ID. If you are confused about what will be the parameter here, you can always open the coupon API controller, and you can notice that when we are getting all, we do not have any. Getting individual, we have the ID. Get by code, we need the code here. When we are creating, we have coupon DTO. When updating, we have coupon DTO. And delete, we only have the ID. Let me make this a put request, and that looks good. With that, we have created the interface for our coupon service. We need to create the implementation for iCoupon service in the service folder. Let me create a new class file. Give it a name of coupon service. That will implement the iCoupon service. And here we need the base service because that is the main class that will be responsible to handle any HTTP request, and it does not matter whether it is a GET, PUT, POST or DELETE. This will be the base implementation for all of our services. If I go back to the coupon service here, we need to inject that using dependency injection. After that, let me implement the interface and all the methods. Right now we have not added the base service or coupon service in the startup, or rather the program.cs class file. We need to inject that first, only then dependency injection will inject that base service when we are requesting it in any other class. Now when we configure the coupon service, we need the URL of our coupon. I can hardcode that in the program.cs, but an ideal approach is to have that inside app settings, and I will create a variable to store coupon API base that will have the base URL for coupon API. Then where will we store the URL? That will be in appsettings.json right here. Let me create a new section with the name of service URLs, and there the first one that I want is coupon API, and we need its URL. To get that URL, we can either run the project or we can go to launchsettings.json in coupon API, and we have that right here. Make sure you get the HTTPS one, paste it right here in the app settings of web project. Next question is, how will we populate this particular coupon API base with the app settings that we have? We will do that inside program.cs of the web project. Yellow color is the web project, so that way I can easily differentiate that. Right here we need to populate static detail.coupon API base. We have builder.configuration, and there we can define the key name. Key name, if I go back, first we have the section name, then we have to write a colon here, and we can pass the key name, which is coupon API. That will retrieve the value and assign it when the services are being configured. Next thing, if you go to base service, scroll up here, we are injecting the iHTTP client factory, but we have not registered anything in the services. In order to register the HTTP client factory that we are using with dependency injection in program.cs right here, we will be adding builder.services.add HTTP context accessor, but the main thing here is the add HTTP client. Once we add the HTTP client here, then we can configure that coupon service will be using HTTP client. For that, we will say builder.services.add HTTP client, and the interface is iCoupon service. Implementation is inside coupon service. That looks good for the configuration. But right now we have only configured the HTTP client. We have not configured in our application that, hey, when we are looking for an I-based service implementation, you need to get an object of the base service. And same applies true for the coupon service. To add that, we will have to register on builder.services, and we have to define the lifetime, which will be scoped. We have the coupon service, and before that, let me add builder.services.add scoped. I want to add the I-base service. With that, we have registered both the base service and coupon service, and also configured the HTTP client right here. With all of that configured, what we have to do next is implement our coupon service. we need to implement the coupon service. First method that we have here is create coupon, but let me start simple. We have the get all coupons right here. For all of the methods here, we need the asynchronous keyword. Let me add that before we proceed further. Perfect. Now where we have the get all coupons, we will add the return statement, await. On the base service, we have the root method, which is send async. There we need to configure the request DTO with the correct parameters. We will create a new request DTO object here, and we need to populate API type. This is a get request, so st.api-type.get. Next parameter here is the URL itself. That is inside static detail. We have the coupon API base, and after the HTTPS, we need to add the API and coupon. Now let me go to app settings here. You can see we do not have a / after the port number. That is why right here we will have to add a /. But with that it will get all the coupons. That looks good. Let me go to get coupon async. There we have to pass the coupon code. When we are getting the coupon code, let me open up the API controller in coupon API, and where I have that, right here I have given a special name, get by code. We will copy that, go back to our coupon service, and right here after coupon, we will add the get by code, and then we need to pass the coupon code. We will add plus and the coupon code. When we scroll down, we have the get coupon by ID. Let me copy and paste it here. And that time, we do not need the custom name here. We only have to pass the ID there. We have update here, but before that, let me copy this, remove the extra semicolon there, and we have delete coupon. For delete, the API type will be delete here, and the URL, if I go back, where we have delete, we are passing the ID. So what we have here is perfect. Now what we are left with is create and update. With both of them, we have to pass the coupon DTO. It will be either HTTP put or HTTP post. Let me copy one of the return statement here without the extra semicolon, paste that for create. The API type will be post there, and next we have something called as data. That data is nothing but the coupon DTO itself. When we go to the base service, we are already serializing that, so we can directly assign the object here. We will serialize that before we send the request. URL here, we do not need any ID. We only need API and coupon. Looks good. Let me copy and scroll down to update here. And the API type here will be HTTP put. That looks good. With that, we have implemented all the endpoints for the CRUD operation in coupon service. We want to see our coupon service in action. But let me close all the tabs here, and when we are working with multiple projects, if I run the application right now, it will only run the coupon API. I want to run both coupon API as well as the web project. We will right click on the solution here, and we have configure startup project. We will select multiple startup project, and we will start both the API as well as the web application. With that configured, let me hit the run button. And perfect, it starts the API, and in the background we have the web project. Right now by default, if you click on the hot reload icon here, you can see hot reload on file save is enabled. Because of that, when I save anything, it will automatically reload the application. If this is not checked, make sure to select that. It will help you when you are testing or debugging few things. But before anything, I want to change the default Bootstrap theme that is there in the web project. I will be using a Bootswatch theme, so let me search for that here. And if we go to themes here, and if you scroll down, you can see we have multiple themes right here. For our project, we will be using the Slate theme here. So let me download that. And once you download, let me open that file, copy that. We will go back to our project. And in the web project, www root folder, lib, we have the Bootstrap default theme. Let me overwrite what we have. So delete everything in bootstrap.css and paste what we copied. If you scroll to the top here, you can see the theme is Slate here. And then if you go back to the application, nothing is updated. That is because if we go back to the project and if we open the master page, that is _layout, you will notice we are using the minified version. We updated the .css, so let me replace that and go back here. Perfect, things are getting different. Before we fix the header here, I want to add a drop-down. So let me search for Bootstrap 5. Go to the documentation here, search for navbar. And we have the drop-down here. Let me copy the li element. Go back to our project. Paste that right here. Perfect, looks good. Let me save that. And if I go back, great, we have the drop-down. You can notice here is drop-down is in blue color. And that is because in _layout, we have a custom CSS behind that. Where we have added a color for anchor tag, we can remove that. If you are not aware of this custom CSS, it is basically a CSS that is bounded to the layout page, and you can see the name is exactly the same. We can remove that, and if we go back after that, perfect, we do not have that blue color anymore. Let me make the header dark here. We will go back to _layout and let me see. Where we have the navbar light, I will make that navbar dark. Remove the background white and border bottom. Save that. Let me see. Perfect. Where we have the text, we will remove text dark. Because we have the dark background, we do not need that anymore. Looks good. Save that here. Perfect. Much better. Lastly, the footer here, let me modify that as well. We scroll down. We have the border top. Let me remove that. And right here, I will add Made with Love by .NET Mastery. Perfect. Now while we are here, let me add Bootstrap icons. Typically, I used to love the font awesome icons, but with the ease of Bootstrap icons, these are becoming my favorite. If you scroll down here, we have the CDN right here. You can see there are many icons that are available to use in our project. It is simple to get started. All we have to do is in _layout, paste that CDN right here. Then if we go back here and if we search for an icon, let's say heart icon, and we scroll down, we have the heart fill. Copy that. And let me paste it here. Go back to the browser. Great. Our footer is looking great, and the header and navigation, everything is aligned with the dark theme. With that configured, we will shift our focus to consuming the coupon API. We need to call our coupon API right here. Let me go back to the application, And right here in underscore layout where we have the drop down, let me change that to be content management. And the first link that we have here, rather than href here, we will go to ASP controller of coupon controller. ASP action will be coupon index. We have not created that, but we will do that very shortly. Save that, and if I go back here, perfect, that looks good. Let me create our first controller. We will do that in the controllers folder. I will have to stop the application, add a new controller. Now this controller will be an MVC and not an API controller because we are working with the web project. I will give it a name of coupon controller. We will go with the empty controller and configure everything right there. In order to invoke the coupon API, we have that in the coupon service. We have already configured that in dependency injection. So let me consume that right here. We add that in the constructor here, and then the index action. If we go back to underscore layout, I am calling that coupon action. So right here, I will rename that to be coupon action. And what will be the return type? Coupon service, if we go there, they are asynchronous method. So here we will add the async keyword, task of I action result. That way, the action method can use a wait keyword. For this particular view here, we want to display all the coupon. We will have list of coupon DTO, and let me call that list is equal to new. We will be getting a response DTO from our coupon service. Let me call that as a response, and that will be await underscore coupon service. Dot we have the get all coupon async. That should retrieve all the coupon. Once we get the response, we can check if response is not null. And we can also check the response dot is success. If that is true, then we can populate list from the response dot result. If we do F12 here, that is an object. We will have to deserialize that object using the JSON convert. We will say JSON convert dot deserialize object, and what will be the type? That is a list of the coupon DTO. Let me add that, and from where we will deserialize that. Before we deserialize, we will have to convert that to a string. And inside there, we will pass response.result. Once we do the conversion, if everything is successful, our list will be populated, and when we return back to the view, we can pass that list. We have done quite a few things. We have added base service, we have added coupon service, and then we added the coupon controller where we are calling the coupon service. Now let me run the application, but before that add a debugging point and let me see if this actually works. Now right now I will tell you it will not work because I have intentionally introduced a bug there. If I press F10, in the response here, you can see the message not found. I want you guys to debug and find out what is going on here. Why did we get the is success to be false and the message as not found? I hope you were able to figure that out. What I did intentionally is in coupon service, you can see the route is API/coupon. But if we go to the endpoint, which is the coupon API, there when we look at the route here, we have the controller name. Controller name will be coupon API and not coupon. To fix that, what we can do is right here, we can append coupon API and that will work. But I do not like that approach. when we actually have to give a route name. If you give it a right name of coupon API and then fix the coupon service, that is okay. But rather than giving it the controller name, I like to give it a hardcode name of the route like this. That way what will happen is in future, for some reason, if the controller name has been updated, then you will have to notify all the client application that, hey, my route is updated. If you do not do that, you will have to remember to change the route to be the coupon API right here. But to avoid all of that, when you start the controller, you can always define a hard-coded route. That way that route never changes even if you update the controller name. I will call that API/coupon, and that is what we have in the coupon service. You can see in all the places we are using API/coupon. With that configured, if I run the application, it should work. If it still does not work, we will debug and see what is going on. Examine the response here, and great. Success is true here, and we have the result. Let's see if it deserializes that, and great. We can see both the coupons and the coupon index is working as expected. Now before we do anything else, we will have to create the coupon index view to display all the coupon. We need to create the view for coupon index. Right click on that action method. We have add view. It will be an empty view. Make sure to give it the same name, that is coupon index. Add that. Now rather than typing the HTML and CSS, I have provided all of that in snippets right here. Make sure to download them from .NET Mastery, and once you download that, in the snippets folder, section 3, we have the coupon index view. Copy that and paste it right here. If you save that and run the application, let me show you what we have by default. We go to coupon here, we go back to the view, and perfect. You can see I have a table layout here, but there are no records. We need to add a for each loop, and we have to iterate through the model that we are passing from, where is that, the coupon controller. Right here, we are passing the list here. For that, we need to define the model of our view. That will be a list of coupon DTO or an IEnumerable. So right here, we first have to define model. That will be an IEnumerable of coupon DTO. Next thing, we scroll down. We have the T body here. We need to add a for each loop and iterate through our model. We have the header here, but in the body, we will add a for each loop. We will say variable item in model. When we are using the model at the top here, it will be a lowercase, but anywhere else it will be a capital M. We will add the closing bracket here. That looks good. And right here, first let me see what we have. Coupon code. So item.coupon code. Next TD, we have the discount amount. We need to convert that to a string. So item.discount amount dot to string here. Change that to the currency format, and let me add one more bracket. Perfect, looks good. We have the minimum amount, that is also a currency. Let me add that here. Perfect. If I save that,